Okay, I will record this meeting and then I will upload into the Google Classroom. So for video that you have to submit, which is one video that compilation of presentation lab 1 and presentation lab 2, you can get from the Google Classroom lah. You can use this recording ataupun you record sendiri you punya own video. Okay, so for each group, I will give around 10 minutes to present in group, and then we're gonna have 5 minutes for question and answer. Okay, and then after lab session today finish, I will upload the video, this meeting video into the Google Classroom, and then you can upload, can download from there, and then you alter the presentation punya video lah. Cut, only use your punya presentation video saja untuk masukkan dalam compilation of report. Okay, before we go to the presentation, again for this lab 1 and lab 2, I will not give the marks. I will not assess you. Your member, your team group will assess you. So make sure, okay, I share again with you the rubrics assessment. So can you see my slide?
Boleh, madam.
Okay, so I hope everyone have this rubric. So you can download from the Google Classroom. I already share with you from the Google Classroom. Okay, so you have to collaborate in team members. This one you tak boleh nak buat individual because your team member will evaluate you. Okay? Please write your name here, metric group. Okay, group ni nanti saya bagi nama lah, isi nombor group mana. And then each member group have to assign for each teammate markah berapa. Okay, let's say focus on the task. Ali want to give Ahmad 4 marks. So 4. So Ali boleh bagi markah, ambil 0.25 darab 4. So 4 times 0.25, 1 marks. Okay, for extend to which work together, 3 marks. So 3 times 0.5, 1.5. And then katalah yang ni 4 juga. 4. Salah. 4 times 0.25, which is 1. This one 2. So 2 times 0.5 is 0.5. So 0.5 plus 1 plus 2.5 plus 1. So 2, 3. So the total is 4/5. And then this one samalah ni. Katakanlah you ada berapa member group? 3 orang. So setiap ni kena isi 3 orang lah. Isi ni name of student here. Ali. Okay, ini kawan you nama Ali. Yang ni nama Ahmad. Lina. Isi for each member group. And after that, you upload this result into the Google Classroom. Clear about how you?
Madam, you will be providing the markings, right? Ada form.
Yeah, I already upload into the Google Classroom. You can download from there.
Okay, thank you, madam.
Okay. And then after you fill the form, you can upload into the Google Classroom. Okay, mai tengok ada tak, saya rasa saya dah upload dalam Google Classroom. I check again. Okay, this one I already put a lab video report. This one, sesiapa yang group mana because of the internet constraint cannot cannot present online, you have to submit the video and upload into the Google Classroom here. This one hanya untuk sesiapa any group who not present today. Okay. Okay, this one you can download from week 5. The peer evaluation form. Whether you want to choose PDF format or you can use Word format. Either one lah. Which one you are comfortable. You can download from week 5 So saya dah upload the form. So you can download from there. So make sure you give all you access all your friends Jangan ada Ali je you bagi markah, Rina you tak nak bagi markah pula. Make sure you marks all your friends and then baru upload into the Google Classroom. Okay. So clear how you gonna mark your friends? Your team member, you bukan group lain your team member. Okay, which group want to present first? Any group? Kalau dah siap present, you boleh left the meeting. Any group want to present first?
Grup saya video, madam. Kalau video macam mana?
Oh, video. Okay, group you video. You dah submit belum?
Belum lagi.
Okay, ada group.
Grup saya pun video media.
Group you video. Okay, mana lagi?
Saya pun video.
Video juga. Nazri?
Video juga.
Oh, semua video. Okay, mari kita tengoklah video tu sekejap. Siapa yang dah submit? Sebab saya tengok ada dah 2 yang turn in ni. Okay. Guru Afikah Musa.
introduce my team members are Nur Arina Shazana binti Azrul, second Nur Zahira binti Arias, and the last Muhammad Haika bin Muhammad. Okay, let's start with the objective is to determine the weight of an object by constructing the vector diagram of the force on the object. Apparatus consists is Newton scale, strings, board, and paper, protector, ruler, 2 types of slotted with holder and pointers. Okay, the procedure, the first step is set up the apparatus as in figure 1. Make sure both of Newton scale is set to 0 Newton. 2. Hang the 10 gram weight holder to the node. Third, place the center of protector behind the node. 4. Place the pointer behind the string to record the angle and the 1. 5. Determine the force of each string. Tabulated the result obtained in table 1. 6 is increase, and the last is increase the mass of 18 10 grams, 50 grams, 100 grams, and 150 grams. Slotted weight to the height order and repeat step 4 and 5. After all the steps is completed, we get the result as below. Let's move on. Let's move to result and analysis. Based on table 1, the higher the mass, both A1 and A2 became lower. Meanwhile, F1 and F2 both decrease. So, the higher force is obtained for the highest mass of the weight, which is 150 grams. Next, I am going to answer question 3. The result of this question is called calculated weight or experimental value. For 1 is F3, we get 0.097 Newton. 2, we get the answer 0.491 Newton. F3 is we get 0.981 Newton, and the last F3 we get 1.490 Newton. Next, I'm going to answer question 4. The result of the equation is called weight and actual weight or theoretical value. This answer I will use to calculate percentage error later. The result for number 1 is we get 0.981 Newton, second 0.491 Newton, third 0.981 Newton, and the last 1.47 Newton. Next, we will calculate percentage error. From the question 3 and question 4, the data we will use to calculate percentage error. First, we get 0% of error to both number 2 and number 3. Next, 1.02% of error for number 1, and the last is 1.22% of error with the highest error. Okay, for the discussion, the result from the experiment is slightly different from the actual weight. It's because when we do experiment manually, there will probably be slight error occurs when the measurement of an object length is more or less than the length because of your eye position at an angle to the measurement marking. And the last of is calculation. In our opinion, the expectation and the reality seem right because the result is not much different. We use 2 meters to find FP and the percentage of error. We could not get the exact value because of some error. Thank you, madam, for the listening. Have a nice day.
Okay, good
Shazana bin Azrul.
Okay, good presentation from Siti Afika, Nur Arina, Nur Anis dan Muhammad Haikal. Go give applause to the group. This group. Congratulations. Okay, what I want to comment is here I want you every member group put a picture of each member group so that I can know you. Kita tak kenal lagi ni. So for each member group, Afika, Arina, Anis and Haikal, put a picture. Yeah, a small picture here beside this name.
Okay, madam.
Okay, and then okay, objective clear.
Pointer. Set up the area.
Okay, here when you do a report, automatic for the procedure, you have to convert the active, the passive sentence into the active sentence. Okay, for example, set up the apparatus as in the figure 1. So you have to convert into the active sentence, which means the apparatus as shown in the figure 1 already set up. You kena tukar ayat dia jadi passive sikit. This one is the given the instruction. This one is the manual, so the sentence is passive in terms of direction. So when you report, you have to make sure you already done the direction. Okay, tukar yang ni sikit. And then my comments, next comment.
Madam.
Ya.
Ada lagi seorang nak masuk ni Google Meet.
Oh, okay, kejap. Manalah? Mozilla pula lah. Saya tak tepi lah. Next.
Answer 491 Newton, 30%
Discussion.
of and the last 1.22% of the course when the
Okay, discussion here. What my comment is, you already stated the cause of the error is maybe because of your eyes not directly positioned at the scale, the measurement scale. So you have to verify this error belongs to what? Macam yang kita belajar last in introduction to the lab. And then you may suggest how to eliminate this error. Okay? Boleh, Syafika?
Boleh, madam. So saya kena edit semula ke for the next video report?
Next video pun tak apa. Tak perlulah, yang ni you dah submit kan. Nanti untuk you combine nanti kan. Combination lab 1 and lab 2 nanti you betulkan dalam tu Okay.
Okay, madam.
Uh, okay, for conclusion, usually for conclusion, we conclude the objective. Back to the objective. What is the objective? To determine the weight of object by constructing a vector diagram. So for your conclusion, you can conclude that here, objective, we from this experiment shows that a vector diagram of force acting on object can determine by using the weight of an object can determine by using a vector diagram of the force acting on the object. Itu you punya conclusion. Okay? The error tu semua you masukkan dalam discussion. Clear, Syafika?
Clear, madam. Thank you, madam.
Okay, thank you very much. This group very good effort. Okay, ada tak yang nak present live before we go to the next video?
Madam,
Ya.
nak tanya apa ni vector diagram tu bukan kena lukis segitiga ke macam
Boleh
mana?
juga. Yes.
Oh, okay.
Cuma for this group dia tak lukis segitiga, dia terus lukis atas graf tu. Kejap ada tak? Ada tak Syafika lukis vector diagram? Syafika, you clear kan kat sini? F1 for this one, for example. Mana? Sekejap saya snap lah. Sekejap. Ya Allah. Selalu. Kejap, ya Allah. Syafika, yang ni,
Ya, madam.
you clearkan sikit dia punya vector diagram tu. Sekejap. Tak clear lah kat sini. Sekejap. Okey, sini pintu. Yang ni you clearkan sikit. Mana lah? F1 kan? F1. Okay, this is F1. Okay, this is F1 Y. Lepas tu satu lagi, this is F1 X. So the angle here is 44. This is 049. Ini. You put here, you can use the same diagram ataupun you put another diagram. Here, buat F1Y and F1X Okay, boleh?
Okay, madam. Okay. Yes, madam.
Okay, good Syafiqah. Okay, siapa lagi yang nak present? Itu saja for group Syafiqah. Ada nak present live? Kalau ada nak present live, kita present live dulu before we check video. Any group? Tak ada, semua buat video ke? Okay, kita tengok satu lagi.
Madam, saya nak.
Atika nak live Okay?
Ya.
Okay, saya stop presenting. You share your slide. Okay, you can share your slide.
Nampak ke?
Nampak.
Okay. Okay, dalam group saya. In my group, there's Adran Atika, which is me, Siti Nuriwani, Ahmad Zaki, and Adam Imani. Okay, so the objective of this experiment is to determine the weight of an object by constructing a vector diagram of the forces acting on the object. Then, to know the comparison each of the calculated weight with the actual weight and the percentage of discrepancy. So the method is hang the 10-gram weight holder to the knot and place the center of protector behind the knot. Adjust the object until the system is balanced and record the results. Place the pointer behind the string to record the angle. Increase the mass by adding 50 gram, and 100 gram, and 150 gram. Okay, so this is the vector diagram that we have construct. So this is F1, this is F2, and this is the angle which is 50 degrees and 43 degrees. This is for the second data. This is the vector diagram for second data. This is the vector diagram for the third data. And this is the fourth. So the weight is F3, which is equals to mass times gravity. Okay, so this is the raw data that we have listed. For the first data, we used 10 gram. The angle is 50 and 43, while the force for F1 is 0.06, and for F2 is 0.08. For data 2, the mass is 50 gram with the angle of 48 degrees and 36 degrees. The F1 is 0.25, while the F2 is 0.40. Data 3, we 100 gram. The mass is 100 gram. The first angle is 44 and the second angle is 33. The first force is 0.49. The second is 0.75. Okay, so we have calculated the weight by using this formula. N equals to F1y plus F2y. So the experimental weight for data 1 is 0.0971, while the actual weight, where we use F3 equals to mg, is 0.0981. For the second data is 0.4909, and the actual weight is 4905. 0.4905. The third data 0.9810, and the actual weight is also 0.9810. For the last data, it's the experimental value is 1.4901 and the actual weight is 1.4715. Okay, so the measurements of the weight are mostly accurate with the actual weight, except for the last data. The resultant value of the first data is less than the actual value by 0.001 Newton. This shows the first data have a high accuracy with the experimental is accurate with the actual weight. For the second data, it is more accurate than the first data, as the difference of the value is 0.0004 Newton, while the third data is very, very accurate, is the most accurate, as it does not have any difference with the actual data. While the last data is high, the accuracy is low because the difference value is 0.0186 Newton. Okay, so to calculate the percentage discrepancy, we followed the steps below. Step 1, we subtract the accepted value, which is the actual weight, from the experimental value. So 0.0981 Newton minus 0.0971 Newton equals to 0.001 Newton. Now we take the absolute value of the first step, which is 0.001 Newton. Then we divide it to the accepted value, the actual weight. Then we multiply by 100 to get the percentage. So the percentage of the first data is the percentage discrepancy for the first data is 1%, while the second data is 0.08%. The third data 0%, and the fourth data is 1.26%. Okay, the value of the resultant in the table is different from the actual weight. Some errors arise from the physical process involved in making the measurements, which are human error, calibration error, and random error. These errors are caused by the observer's collaborating process, where they mark the position of the string on the blank paper inaccurately. So hence there would be a different result than the actual value. The reading of the scale by the observer may also be the source of the inaccuracy. The scale is the Newton scale, where it probably was not stable, but the observer has made a decision to read the scale, to read the value. So the result from the experiment agrees with the actual value. This is because the differences between the experimental value and the actual value are small. So the conclusion is our expectation of a linear relationship between weight and force seems correct. The data supports this notion very well, as the data will increase in the graph. When the number of weight increases, the number of force also increases. Okay, that's it from me. Thank you.
Okay, thank you, Atika and your group. Very good effort. Clear. Okay, what my comments is, can you scroll up?
Okay.
Okay, raw data. Scroll down. Okay, here. Okay, for the data analysis, you already analyzed the raw data and you already give documented all the calculation that you already done. But here, I want you to more explain detail more how you get the F3. So F3 here, you already calculate and the result is 0, for example, 0.0971. So how you get this value? Okay, you apa tu? You put another column before F3, F3, F1Y, F2Y. You calculate that one, and then the product of these two F contribute to the F3. So put another column there. Clear, Atika?
Clear, madam.
Okay.
You mean so I have to add here under the raw data?
Yes, before you can come up with the F3, you have to calculate F1Y, F2Y kan? So put that one in the table also.
Okay.
Okay, you scroll down. Okay, this one also to calculate the percentage of error, you have to put in the table also for each measurement, for measurement 1, for measurement 2. So for each measurement there are some error, whether this 0% or 1%.
Okay, madam.
This one oh you dah letak kat sini. Okay, and then I think that's all for my comment for this experiment. Clear? You just put your member group and your picture in this video later.
Okay.
Okay, good. Atika. Next group. Anyone to want to present online before we go through the video? Any group? Tak ada? Semua hantar video. Okay, we go to the video. Okay, I share my slide. Farhan. Akmal.
Question 5. Question has to data obtained in table 1. value were given. And the next question asks, construct the diagram of each of the mass obtained in table 1. So the vector diagram looks like this. F1 equal to 0.06 meter, F2 0.08 meter, and the angle is 50 and 43 degree. And we can calculate the F1y by using the cos 50 multiplied by 0.06 equal to 0.039. And for f to y, we can use cos 43 multiplied by 0.08 equal to 0.059. And for f3, we know that f3x is equal to 0 and f3y this is the mass event. To find the weight, we use this formula f3 equal to mg equal to 0.01 multiplied by 9.81 equal to 0.098. And from the Newton's law, the sorry, this was supposed to fy. The total of the fy equal to all the force in the diagram. Total of all the force in the diagram. F1y plus F2y minus, because this is going downward, minus F3y equal to 0. So this is the Newton's law. And used to check whether it is same or not. F3y equal to F1y plus F2y. So both we get 0.098. It is same. For the next one is for the mass given is 60 gram. For F1 equal to 0.25 Newton and F2 equal to 0.4 Newton. So the angle is 48 for this side and 36 for this side. So we can find the F1y by using the cos 48 multiplied by 0.25 equal to 0.167 Newton. So the second one is F2y. F2y equal to cos 36 multiplied by 0.4 equal to 0.324 Newton. And same like before, to find the F3, we use the formula, weight formula, and 0.05 multiplied by 9.81 equal to 0.491 Newton. So from that, we can find the total. Sorry, this was Fy, not F3y. The total of the Fy in the diagram, F1y plus F2y minus F3y equal to 0. So this is because it is balanced. We are going down equal to 0. So F3y equal to F1y plus F2y. So both we get 0.91 Newton. For the next one is F3 equal, the mass given is 100 gram. F1 equal to 0.49 Newton. and F2 equal to 0.75 Newton. And the angle is 44 and 33. So this value we get from the data lab given. So we have to find the F1y, the force that upward, cos 44 multiplied by 0.49 equal to 0.352. And F2y we find the upward also. Cos 33 multiplied by 0.1 multiplied with 0.7 Newton. F2 equal to 1.12 Newton. The angle is 42 degree and F1y equal to cos 42 multiplied by 0.7. The total of the 1 point as given. So this one is for this actual of some different. Number 4, there is a slight error of 1.208% at 0 Newton. Only at number 4 have slight errors. For conclusion from the experiment, submission force in the value is always equal to 0. That's all from our representation. Thank you. A slight error of 1.2.
Okay, thank you very much, this group. Okay, for my comment is, you have to report this one. You have to present in form of report format. So you must have objective, apparatus, procedure, the result, the discussion, and also the conclusion. Yeah. So for this group, a very good effort to come up with a video, but you have to write your own report. So for the next video, I hope you can write your own report. Bukan yang ambil daripada manual. So this one you directly read from the manual. Okay, write your own report. Okay, and then for the explanation, I hope this group can put all the data, the analysis that you get in form of a table. Dalam bentuk table. When we write the report, physics report, usually all the data we put in the table. So I hope you for this group can do some correction, put all the analysis and all the data in form of a table. Okay. Okay, and then for conclusion, for discussion, I don't hear any explanation that contribute of this error. Tak tahu aku saya termiss, but for the next video, I hope the submission of your video, I hope you can put the explanation that contribute for this error, the source of the error that we already learned in the introduction to the lab. Okay, and then for conclusion, I think you state the apa tu? F equal to 0 kan? Okay, good. Okay, this one Okay, the summation of F always equal to 0, betul. This is true, but this is not the conclusion for this experiment because this one is referred to the chapter 3, the Newton's law. What I mean here, I want you to conclude that by using a vector diagram, you can determine the weight. You refer back to the apa tu objective because this experiment is about vector. So by you can determine the weight of an object by using a vector diagram. Itu dia punya conclusion So apa tu buat correction sedikit. Itu saja from my comment for this group. Very good effort. Okay, boleh boleh betulkan? Group
Boleh madam, boleh.
betul
Boleh madam, boleh.
Okay, next group. Mana lagi group yang want to present? Ada tak yang nak present online? Ada? Okay, kita tengok group Akmal Harif. Dah kan tadi? Farhan Danish.
Assalamualaikum warahmatullahi wabarakatuh.
9 minit.
We want to determine the weight of the object by constructing of the vector diagram of the force on the object. The apparatus is shown in this slideshow. Go through the procedure. This is the procedure. In figure 1, this is the experiment. This is the data lab. One mass gram, 10, 50, 100 gram, and 150 gram. Number 2, we need to construct a vector diagram of each of the mass contained in table 1. So, the weight that's shown in this graph is F3Y straight down, which is we use the gravity force. Okay, next is how to determine the weight from the base on the vector diagram. We can use the formula F equal to mg, which is F is a force, m is a mass, and g is a gravity. For the mass, we should convert gram to the kilogram. In this show, I will show how to compare each of the calculated weight of the vector diagram with the actual weight. So first of all, we must know the mass that has been given in the data, so that we get the first mass in diagram. So we must check first into the kilogram. So we will get the 0.01 kilogram. So how to find the weight? We will use the formula that S equal to mg. So m is equal to 0.01 multiplied by the gravity that we know is 9.81. So we can get the actual equal weight. Then we know that the weight it is left is balanced to the first one and first two. So we can convert it into the formula that is SDY as the weight equal to F1Y plus F2Y. So after that we can get the calculated weight. So then in this question, we must get the percentage error. So we can the formula calculated weight minus actual weight per actual weight and multiply by 100%. So we will get the percentage error. After that, we change mass and by so I think that everyone is agree with the actual value. Get 0.01 2 0.0%. Number 3 is there is no so error and error that occurs when it is not calibrated correctly. Error will result that either constantly lower or higher than the but by a certain percentage. An example is that the experiment value for class diagram is lower than the actual value. And the percentage is negative 1.02%. For math, if the gram the experiment value is higher than the actual value, it is not percentage 0%. Procedure human error, the observer level of the parallel here I will give the mechanical law. If f is always equal to 0, so the mechanical law is that an object at rest will remain at rest or continue to move with uniform velocity in a straight line unless it is at a point by the external force. So the transmission of force in the balance are always equal to 0. That if we calculate the force in y-axis, we will get the 0 because the force is balanced and not move. Come from it. Thank you.
Okay, thank you very much for this group effort. Farhan, Arif Aiman, Hakim, very good effort. Congratulations. Okay, for my comments is vector ni spelling salah ni. Okay, my comment is okay, please put all the procedure also, the written procedure also, but in terms of active word, active sentence. Okay, mana tadi?
Okay. Next is how to determine the weight from the base on the vector diagram. We can use the formula F equal to M.
Okay, construct vector diagram. I think you already done that part.
The vector diagram, which is F is gram to the kilogram. Second relative weight of the vector diagram.
Ini salah ni. Sekejap Determine the weight from the base on the vector. Vector. This one you not get from the vector. This one is actual weight. You use your formula mg. So this one f3 equal to f1y plus f2y. So yang ni kena betulkan sikit. You have to do some correction here. Yang ni you put there. And then here you calculate the the actual weight, and then you compare here. Okay, again here, make sure you put all your data in table. Okay. Okay, the discussion examine the result. Actually, apa ni? You kira apa ni? Ni apa ni? Ini absolute error. Put the apa tu? The description here. Okay, for the source of error, you explain maybe the cause of the error is maybe the calibration error and the human error. Okay, I already heard you explain for each what is the calibration, what is the human error. I want you to put all the explanation also in the written sentence. Okay, this is absolute error, and I hope you can calculate also the percentage of this error. Because the question asks you to find the percentage of discrepancy. Okay. Okay, again, conclusion. I think you get the wrong conclusion. You give the wrong conclusion. Although we use the Newton's first law here, but this is not our objective here for this experiment. For this experiment, the objective is a vector diagram. Vector to determine the weight of a measure of an object using a vector diagram. So this is our conclusion. You have to relate the objective into the conclusion. Okay, that's all my comment for this group. Can you do the correction? Tapi apa tadi group member group? Boleh? Boleh?
Boleh.
Alif, Farhan, Ikwan dan Haikal Okey, ada group. Ada lagi tak yang nak present? Ada lagi tak group yang nak present? Ada lagi yang nak present? So kita dah present 4 group. Ada lagi 2 group yang tak present. Ada tak member group kat sini? Anyone? Okey lah, saya rasa yang 25 orang. Ada tak antara 25 orang ni yang nak present lagi? I hope you can present today because kalau tak, we have to slot another time. Mana? Ada lagi tak? Saya tak check pula dia punya apa tu, member group. Yang lain? Boleh? Anyone to present today? Senyap semua ni.
Tak tahu.
Lah yang lain tu. Tapi ada 25 orang hari ni. Okay, tak apalah. We stop here for our lab session. The others two group, you have to contact me and then you have to present. Whether you will use video ataupun tidak, you have to contact me. Okay, so for the 4 group that already presented, you do the correction. And then when you, kita dalam minggu ke-8 nanti, when you compile lab 1 presentation and lab 2 presentation, baru you correct the video yang the correction video lah. For this time, no problem. You already submitted. Maknanya you already complete the task lah. Okay, and then apa tu? Sekejap. Oh, ni. Okay, nanti saya letak satu folder untuk submit the peer review punya form. Okay. So, nanti you dah isi borang-borang ni, you submit dalam Google Classroom. Okay, I think that's all. Any question? Any question from you?
No, madam.
No, madam.
No, madam.
No, madam.
So, I think we stop here lah. Thank you very much. Untuk group mana tadi? Group Atika, nanti you can get the video after I upload into the Google Classroom and you just edit, you only cut your video, you punya video presentation, yang lain the rest tu you buang lah.
Okay, madam.
Okay,
So
thank you very much.
do I have to resubmit the one that I cut?
No need, because your presentation we already recorded and I upload into the Google Classroom.
Okay. Thank you, madam.
Any question? Tak ada? Okay, thank you very much. We stop here. So see you tomorrow for class, our class. Okay, you can leave the meeting room.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam. Stop the recording.